Hi, and welcome to an architecture overview of the Internet of Things, or what it's more commonly referred to as IoT. Today, we'll be discussing the fundamentals of IoT and seeing how we can simulate IoT devices. Before that, let's get familiar with IoT and see what it's all about. IoT is a network of things that can communicate with each other and act upon that data if and when necessary. It's the brainchild of Kevin Ashton, who conceived the notion of a network of things in 1999. Kevin's idea was to effectively turn the world into data and to have decisions made upon that data in a completely autonomous way. It would reduce waste and increase efficiency. Things would generate, collect, and exchange data and then act upon the information if necessary. The goal is to eliminate, or at the very least, reduce human computer interaction. How IoT works is really simple. Any smart object that has the capability to collect and send data becomes an IoT object. This object would be web enabled to communicate with either the internet or a local IoT network. A network with smart objects is able to act upon data and make decisions based on preference and previous data. No input is required from a person. Everything happens automatically via machine-to-machine communication. Let's look at an example of how you would see an IoT device network operating. A climate sensor detects that the air has become too humid. To reduce the humidity, the air conditioner should be turned on. The sensor sends the message to the IoT gateway that then decides based on user preference what to do. If the user wants the AC to be turned on automatically, the command will be sent to the AC to turn on. Alternatively, a notification could be sent to the user's phone about the humidity level in case they want to manage it themselves. This is just one example of the many things that people are doing with IoT. The world as we know it today is only possible because of the applications of IoT. From our homes to our health, and even the food we eat, all of it is managed more efficiently using IoT. The most common usage of IoT is in smart homes, where most, if not all, electronic appliances are controlled via a network. Let's move on to the second section, where we will examine the details of how IoT functions. For that, let's start with the structure of IoT and what comprises an IoT object. What makes up IoT? Well, that would be smart devices. But what separates a normal wristwatch from a smartwatch? What makes a normal item turn into a smart item? The answer to that is something we've already discussed in the previous section: the ability to collect and send data. The way we can give things the ability to do that is to embed them with the ability to either tag, feel, think, or shrink them down to nano size. Let's start with tagging. You're probably familiar with NFC tags that people use to locate their keys and pets. These tags are also found in touch key cards, like the Oyster card used in London for public transport. These tags have unique identifiers and make searching as well as accessing much easier, simpler, and smarter than ever before. Feeling. This is a more common form of IoT devices. Sensors are used to collect information and transmit that information to the IoT gateway. From there, it is decided how to act upon that data. Sensors are in most things today. Modern phones use tens of sensors just to function. It allows for medical emergency responders to know when to dispatch before the person may even realize. Thinking is an aspect of IoT that I find kinda scary. Some IoT devices are capable of making decisions all on their own, with no outside help. We say that these devices have been given embedded intelligence so that they can make sense of the data they collect and make decisions accordingly. Self-driving cars are based on this principle. Tesla cars, for example, can drive themselves on the road and will stop if they sense an emergency on the road. They will even speed up or slow down with traffic. It's as if the car is thinking about its movements all the time. Scary, right? In this third section, we will be looking at how IoT communication happens and seeing how information flows in IoT networks. After understanding this section, we'll be simulating IoT devices to the cloud. Now let's take a look at how communication happens within IoT. As we discussed in the previous section, IoT communicates through messages. The protocol it uses to send those messages is called Message Queuing Telemetry Transport, or MQTT for short. It uses publish and subscribe messaging protocols on top of conventional TCP/IP. Now, if you don't know what TCP/IP is, feel free to pause this video and go look at the TCP/IP communication layers and protocol. The publish and subscribe model is very similar to the way YouTube works. On YouTube, if you like a channel's content and want to see more of their uploads in the future, you subscribe to the channel, and whenever there's an update, you get a notification. In IoT, it works the same way. An IoT device, like the thermostat in our example, is a publisher. It publishes temperature information. The MQTT broker serves as the middleman between clients and takes the temperature messages from the thermostat and puts them under a topic called temperature. Now a subscriber can subscribe to that topic of temperature, and whenever the thermostat uploads an update on the temperature situation, the subscriber gets notified. This is how IoT devices communicate with each other via IoT gateways. The data moves from the application layer down towards the device layer. If you know about the TCP/IP model, this would look very familiar to you. On a high level, this is how messages are communicated within IoT networks. Now let's see how we can apply our knowledge of IoT in the real world. Okay, so let's see how we can simulate IoT devices to an IoT hub. To simulate these devices, today we'll be using Azure's IoT hub. The reason for that is it's really simple to work in. It's not got a lot of hiccups associated with it, and it's generally well associated in the IoT space. So it should be a comfortable user experience for somebody who's new to working in IoT and has no prior experience. So let's take a look at the resources that we'll be using today. The first thing we need is an Azure account. You can get a trial account or a student account, and both accounts will provide you with the resources that you need to set up an IoT hub. So you can get that account really easily. Just make an Azure trial account if you don't already have one. The second thing we're going to need is an IoT device. And to do that, we're going to use Azure's IoT Raspberry Pi online simulator. This is a really simple simulator. There's really not too much to it. And what it does in essence is it just has some temperature readings and humidity readings that it sends over to the IoT hub. And it blinks the LED. When it does that, there's this code here. It's associated with the Raspberry Pi. We're not going to go too far into the depth of this code because it's not really the focus of this course right now. But if you want us to do a separate course on virtual Raspberry Pis and you want to see how to simulate Raspberry Pis and the sort of things you can do with that, drop us a comment below and we'll try our best and we'll make a course on that. Now the last thing we're going to need is a way to see the messages that we send to our IoT hub. For that, we're going to be using Visual Studio Code. I know it's an IDE. Don't panic. You're not going to be writing any lines of code for this. The only thing we're going to be using is the telemetry that the IoT hub within VS Code provides to look at the information that we're sending to our IoT hub. So let's get started with the IoT hub. When you come to your portal in Azure, you just want to go to the top search bar and search for IoT hub. you'll see the service down here called IoT Hub. You can click on it. It'll bring you to a page like this where you can create your IoT hubs or you can manage existing IoT hubs. So because I'm assuming that you don't have an IoT hub already made, that you're going to have to make one, let's go through the creation process and see how to make an IoT hub. So the first thing that you're going to see is it's going to ask you for which subscription you want this IoT hub's charges to go to. For us, since Skill Curb uses a Azure for Students account, we will be sending that to our Azure for Students account. As for the resource group, we can send this to any resource group. Again, this is for what the resources, where it gets the resources or what resources it's allowed to use in order to make the IoT hub. For instance, we can give it any instance name. We can call it SkillCurb 2, since we already have one. And for the region, it's recommended that you go for whichever region is generally closest to you. For example, if we were doing this from, say, India, then maybe Central India would make more sense for us to have. Or if you were somewhere in Australia, whichever side of Australia is closer to you, or Southeast Asia. For me, it's Southeast Asia, so I'm going to go for Southeast Asia. Then we move on to networking. This really isn't too technical. The definition's right here. You can connect your IoT hub either publicly or via a private endpoint. And that doesn't really matter for somebody who's just running out an IoT. You can just leave this public and move on to the next tab. Now here it's really important, the scale tier and units. Now, if you go for the S1 tier, you need to keep in mind that it will charge you $25 a month to run an IoT hub within the standard tier in Azure. So in order to avoid that, what we can do is we can go down to the free tier right here. And as the first IoT hub we've made is a free tier, it won't let us make another one, but it'll allow you to have 8,000 messages a day, and it won't charge you anything in a month. So that's the smart way to go if you're just trying out IoT, getting your feet wet and getting to grips with what it is in general. As for the second thing down here that says role-based access control, this is a shared access policy, or I could go into the depth of this, but for our demonstrations, this doesn't really matter. What it effectively says is only people with roles can access this IoT hub, or if we can share this IoT hub with other people, and the people with roles can also access it. This little checkbox here below, assign me to the IoT hub data contributor role. This is kind of important because this is a role that you need to grant yourself the complete access to the APIs that have complete access control to your IoT hub. It even says so here. To manage the elements within an instance, a user needs access to IoT Hub data APIs. Select the suggested role below to grant yourself full access to the APIs. You can also use Access Control IAM to choose appropriate roles later. This is required, I would say. You should keep it handy because even if you don't use it, it gives you a lot more control within your IoT Hub, and so you should have this. You should leave these advanced settings for now. We'll get into them in a more detailed course, but for now, these advanced settings do not matter. Let me move on to tags. This is simply a way to understand what it is, how it's going to show up on your bill. So we can call this Skill Curb Second IoT. We can just give this a value of IoT Second, right? And this will show up as a resource. It's just for your billing, nothing else. And when you finally go to review and create, it's going to validate your settings for your IoT hub. And then it's going to let you know if you pass your validation. We have passed validation. And so we can create an IoT hub with these settings. But since we already have an IoT hub, we're not going to be creating one. You, on the other hand, may not have one. So I would suggest you create an IoT hub. And then when you have an IoT hub created, it will show up like this in your IoT hub. Our IoT hub is called Skill Curb. And so we're just going to go there. and open it up. So this is what your IoT hub should look like when you have it all set up. So now we have this set up. We can see here that we use one message today, no devices set up, and this message doesn't matter. Apart from that, we don't have any devices right now in our IoT hub, and I can show that to you. If it retrieves devices, there we go. We don't have any devices set up in our IoT hub right now. So the first thing we need to do from here is to let our IoT hub know, okay, look, I want a device to send messages to the IoT hub, right? So I have to therefore create a device within my IoT hub and say, this is the device that I will be using to send telemetry. So since we're going to be using a Raspberry Pi and I like to make sense of things, I want to call this Raspberry-Pi. That way it's identifiable. I'll know which device I've assigned this to, and it wouldn't cause me any confusions or problems later on. Now it'll take about 2-3 seconds or minutes depending on how good the connection is, and you should have a device like this ready to go in seconds. Now, when you have this all set up, you will see that on your fourth row, it'll say primary connection string. This is the string that you will be using to connect to this device within your IoT hub. So when you have an IoT smart device that has to send telemetry to the hub, it will be asking for a connection string. It'll want to know, where do I send this data? And it receives that information from the primary connection string that we have here. So we can unhide it and we can see that's what it's called. Okay, fine, fair enough. We can copy this information and take it over to our Raspberry Pi simulator. Over here on the 15th line, we have our connection string. Over here, it says your IoT hub connection string. We replace this bit of code, or the bit of text actually, and put our hostname or our connection string in there. So now this is ready. This is now ready and set up to send data. And we could send data if we wanted to. However, we'd have no way of knowing what data we've received. We would receive the messages. We would know that we've received messages, but we wouldn't know what was inside those messages. Not until we set up the telemetry to understand and read what those messages are. So now we have to set up the console for reading the messages that we're going to get from our IoT device. And for that, we're going to come to this link here. All the links are going to be shared in the description below, so don't worry, everything will be provided. So when we get to here, it shows you that you need to have Azure IoT tools for VS Code, or you can copy and paste this URL into the browser. This is honestly a much more simpler method, at least for me. But before this, you do need to have VS Code downloaded and installed. So when we have VS Code downloaded and installed, we can use this link. It'll want to open in VS Code, and boom, it brings us right here. And now because I already have this installed, it's giving me the option to disable or uninstall. But for you, it'll most likely just ask you to install it, and then there will be a connection process that you can follow to connect your VS Code Azure IoT Hub to your actual Azure account. So when that's done, you'll see it in your Explorer on the left side. You'll have your Azure IoT Hub. And see, we have skill curve here. We have our devices here. It's showing up Raspberry Pi. So now from here, we want to start monitoring the built-in event endpoint. And so we can start doing that. Start monitoring message arrived in built-in endpoint for device Raspberry Pi. It makes the partition receivers. And now let's go back to our Raspberry Pi and start sending messages. There we go. sent a message with ID 1, 2, 3, 4. I think we should stop it at 5. Okay, so we have sent 5 messages. 1, 2, 3, 4, and 5. Right? And so we had one message in our IoT hub when we started. Let's see how many we have now. Okay, there we go. We have 4 messages. So of the 5 messages, we received 4. And now let's go to VS Code. There you go. This was empty before, and now we have all this telemetry where we got a message ID with 1, got the device ID, Raspberry Pi web client, temperature 20.25, humidity 74.18, and it just keeps receiving these messages. 2, 3, 4, 5. It's received all these messages. There we go. 4 messages. So I guess we didn't really receive the 5th one, but that's not a problem. But we got most of our messages. And you can now that you understand this, and if you understand a bit of this code, you can even play around with it. Like, for example, if we have device ID, we can just call this skill curve Raspberry Pi, right? And then when we start running this, we start sending the message ID 1, device ID skill curve Raspberry Pi. And we can go back to our debug console and see we're now receiving messages with skill curve Raspberry Pi. So that's the beauty of how the simulator works, of how even IoT works. And you can see from here how the information flows, how it moves. And I hope this has been a fun demonstration for you. I hope that you've enjoyed. And if you like what you see, the content and the demonstrations, please do like and subscribe.